Hello everyone, my name is Ankit Verma and today we are learning the naïve based classifier. Here we have given the dataset in which the first thing is day. So D1, D2 up to D14. So these are the 14 days. Then we have 4 attributes. The first attribute is outlook, which can be sunny, overcast or rain. So these are the 3 possibility. The second attribute is temperature, which can be hot, mild or cool. So these are the 3 possibility. The third attribute is humidity, which can be high or normal. So these are 2 possibility. The fourth attribute is wind, which can be weak or strong. So these are 2 possibility. Next we have one target variable, which is play tennis, and it can be no or yes. So these are 2 possible outcome. That means it is the binary classifier. And here we have given the instance with some condition, just like outlook is sunny, temperature is cool, humidity is high and wind is strong. Now we are understanding the problem. So here we have given with the data set where the days are available and different attributes are available, and the outcome is playing the tennis, yes or no. So here they are giving an instance with the condition that if outlook is sunny, temperature is cool, humidity is high, wind is strong. So can we play the tennis, yes or no? So we has to find out the outcome of playing tennis as yes and no for this instance by applying the naïve Bayes classifier. First of all, we are finding the prior probability. Prior probability is just for the target variable, which is the play tennis. And there are 2 outcomes, yes and no. So first we are considering playing tennis equal to yes. So the probability of playing tennis equal to yes, that will be equal to, now we are counting the yes. This is 1, 2, 3, 4, 5, 6, 7, 8 and 9. So here we have the 9 yes. So that will be equal to 9 divided by total, and the total we know is 14. So 9 by 14. Now we are checking for play tennis equal to no. So the probability of play tennis equal to no will be, so here count the no, which is 1, 2, 3, 4 and 5. So it will be 5 divided by total, and the total is 14. So these are prior probability. Now we are calculating the current probability. It is also called the conditional probability. Now we are going to find out the current or conditional probability of each attribute. The first attribute is outlook, and it can be sunny, overcast and rain. And the outcome of playing tennis can be yes and no. So here we are going to find out the probability. So in the outlook, we are taking this attribute, and the first thing is sunny. So here we are highlighting all the sunny and their corresponding outcome of playing tennis. So for the sunny, we are checking how many yes are there. So here only 1 and 2. So 2 yes are there. So 2 divide by, now how many total yes can come? And we know that the yes is 9. So 2 by 9. And the remaining are no. So 1, 2 and 3. So 3 no are there, which is dividing by total number of no. And we know that this is 5. So 3 by 5. Now we are checking for overcast. So here in the outlook we are highlighting the overcast and their corresponding target output. So here we are checking number of yes in overcast, which is 1, 2, 3 and 4. So 4 divide by total number of yes and that will remain same, which is 9. And for the no, check number of no's. So there is no available. So that will be 0 divided by total number of no's, which will remain 5. Similarly, check for the rain. So here we are highlighting the rain and their corresponding outcome. So rain, yes. Now we are counting the yes. So 1, 2, 3. So 3 divided by total, which will be 9. Now counting the no. So 1 and 2. Here 2 divided by total no, which is 5. Now we are checking the current or conditional probability for temperature. Temperature can be hot, mild and cool. And the outcome of playing tennis can be yes and no. In the similar manner, in the temperature, first of all, highlight the hot and corresponding outcomes. So for the hot, yes, number of yes are 1 and 2. So 2 divide by total number of yes, which is 9. And hot for no, so 1 and 2. So 2 divide by total number of no, which is 5. Now check for the temperature mild. So highlight all the mild and their corresponding outcome. And number of yes are 1, 2, 3 and 4. So 4 divided by total yes is 9. And number of no's are 1, 2. So 2 divided by total no is 5. Now check for temperature cool. So highlight all the cool and their corresponding outcome. Now number of yes are 1, 2, 3. So 3 by 9 and number of no are 1. So 1 by 5. Now check the current or conditional probability for humidity, and it can be high or normal, and the outcome can be yes and no. So in the humidity, first of all take the high and highlight all the high and their corresponding outcomes. Number of yes are 1, 2 and 3. So 3 divide by total, which is 9. And number of no are 1, 2, 3 and 4. So 4 divide by total, which is 5. Now check for the humidity normal. So highlight all the normal and their corresponding outcomes. So number of yes are 1, 2, 3, 4, 5 and 6. So 6 by 9. And number of no are only 1. So 1 by 5. Now we are checking the current or conditional probability for wind. which can be strong and weak, and the possible outcome can be yes and no. Now check the wind for strong. So here highlight all the strong and their corresponding outcome. So here yes, number of yes are 1, 2, 3. So it is 3 divided by total number of yes, which is 9. And number of no are 1, 2, 3. So 3 divided by total number of no, which is 5. Now check for weak. So highlight all the weak and their corresponding outcome. Now check for yes. So number of yes are 1, 2, 3, 4, 5, 6. So 6 by 9. And number of no are 1, 2. So 2 by 5. So till now, from the given data set, we have calculated the prior probability, which is for the possible outcome for the target variable, which can be play tennis, yes and no. And these are the yes out of total and no out of total. Then we have calculated the current and conditional probability for the individual attributes, which are outlook, temperature, humidity and wind. Now we are writing the formula for naïve Bayes classifier. This is the equation of naïve Bayes classifier, which is equal to argmax, and here we have Vj. Vj is possible outcome, and this outcome can be yes and no. So here probability of Vj means probability of outcome, and product of probability of Ai. Ai is set of attributes divided by Vj, which is outcome. So the equation of naïve Bayes classifier is argument max Vj, which is possible outcome, that is yes and no. So probability of possible outcome and product of probability of attribute divided by outcome. Now we are going to expand this. The product of probability of all the attribute divided by outcome. And here we have the 4 attributes which are given to us. And these 4 attributes we are going to take the product. So this portion will be as it is. And now we are taking the product of all the attributes divided by outcome. Now the probability, so here we are taking the first attribute from the instance, that is outlook equal to sunny. So here we are writing sunny as attribute divided by Vj. Then the next attribute, because this is the product, so we are taking the another attribute, that is probability of, that is temperature cool, again divide by Vj. Then product of, so here probability of humidity is high, divide by Vj. Then product of next probability, which is wind equal to strong, divide by Vj. So this is the product, and here we have taken the product of all the probability of sunny, cool, high and strong, divide with the Vj. Now we are taking the naive Bayes equation, and here we are taking the yes for the Vj. So all the Vj we are going to replace with the yes. So that will be equal to probability of yes, then probability of sunny divide by yes, and probability of cool divide by yes, then probability of high divide by yes, and probability of strong divide by yes. Now we are putting the values, so that will be equal to probability of yes. This is the prior probability of yes, that is 9 by 14, multiply with the probability of sunny as yes. So sunny and yes is 2 by 9, multiply with probability of cool yes. So cool and yes is 3 by 9, multiply with probability of high by yes. So high and yes is 3 by 9, multiply with probability of strong by yes. So strong and yes is 3 by 9. That will be equal to 0.0053. Now take the naive Bayes equation for no. So here Vj is taken as no, that means put all the no in the Vj. So it will be equal to the probability of no multiply by probability of sunny by no into probability of cool by no, and probability of high by no, multiply by probability of strong by no. Now put all the values, so that will be equal to probability of no is the prior probability of no, which is 5 by 14, multiply with probability of sunny as no, which is 3 by 5, multiply with probability of cool as no, which is 1 by 5, multiply with probability of high by no, which is 4 by 5, multiply with probability of strong as no, which is 3 by 5, and that will be equal to 0.0206. Here we can see that the value of yes, which is 0.0053, this value is smaller than the value for no, which is 0.0206. So this is the large value, which means the no probability is high. So using the naive Bayes classifier, the no probability is high. So here for the given instance, if outlook is sunny, temperature is cool, humidity is high and wind is strong, then we are not going to play the tennis. We can also consider the denominator, but the answer will be same. So we are taking the denominator as well. So naive Bayes for yes, that will be equal to naive Bayes for yes divide by naive Bayes for yes plus the naive Bayes for no, and that will be equal to yes is 0.0053 divide by, yes, again 0.0053 plus no, which is 0.0206. It will be equal to 0.205. Similarly, for naive base for no, that will be equal to the naive base for no divide by naive base for yes plus naive base for no. That will be equal to, no is 0.0206 divide by 0.0053 plus 0.0206. That will be equal to 0.795. Here also we can compare this 0.205 and 0.795. This is large, means probability of no is high. So for the given instance, we are not going to play the tennis. The important thing to note is the sum of these two will be 1. So here from the given data set, we have taken the prior probability, then current or conditional probability for all the attributes. Then for the given instance, we have applied the naive Bayes classifier, and we concluded that for this instance, we are not going to play the tennis. So that's all for today. Thank you.